Today class will discuss on cane sugar industries as a part of municipal and industrial wastewater engineering. In India, most of the sugar industry are the main basis for our country economy. This industry operates about 4 to 8 months after the harvesting of the sugar cane. A large volume of waste of organic nature is produced during the period of production, and normally they are discharged onto the land or onto the nearby water source, usually small streams, practically without treatment. How this sugar is manufactured from the sugar cane? Firstly, sugar canes are cut into pieces and crushed in a series of rollers to extract the juice in the mill. Then sugar cane, the milk of lime is added to the juice and heated, where all the colloidal and suspended impurities are coagulated. So here lime will be added to remove colloidal and suspended impurities. The filtrate is recycled to the process, and entire quantity of clarified juice is treated by passing sulfur dioxide gas through it. The process is known as sulfate process. So sulfate is a process where juice is treated by passing sulfur dioxide gas through it. The clarified juice is then preheated and concentrated in evaporators and vacuum pans. Partially crystallized syrup from the vacuum pan is known as mesacutide, is then transferred to the crystallizer, where complete crystallization of sugar occurs. So the steps will be involved is sugar cane taken to presses, converting to juices. Once converted into juice, we're going to add lime to remove suspended and colloidal particles. Then entire juice passes through sulfur dioxide gas. This process is called sulfidate, and then juice will be preheated, concentrated in evaporators and vacuum pans. So we'll get partially crystallized syrup is called mesacutide, is then transferred to the crystallizers, where complete crystallization of the sugar occurs. The mesacutide is then centrifuged to separate sugar crystals from the mother liquor. The spent liquor discarded as a black strap molasses. The black strap molasses can be used in the distillery for the production of alcohol. So this is the typical flow chart of sugar industry waste. Okay, so first will be cane supply, it will be washed and crushed, then one part bagasse, it go for reuse like for the fuel or for paper industry. Then second, cane juice, lime will be added. First it can be filtrate for clarification, the filtrate is go for the solid waste, then clarification process, then later next process will be sulfination, then you go for evaporators where the syrup will be added in a vacuum pan, then crystallizers and centrifuged molasses for the spent wash, and sugar will be collected on the other side. So this is the process of cane to sugar. Sugar cane converted into sugar. So here various process will be coming into part. Then where will be we're going to get wastewater from the grain where sugar cane will be crushed, where during the washing we're going to get wastewater. Then filter cloth washing, then boiler house leakages etc. In operators condensing water will get it. And pond in a vacuum pan, you're going to have a cooling towers where you're going to get sufficient amount of wastewater, and in the molasses you're going to get water. So all these places you're going to get wastewater for treatment. The sources and characteristics of waste. The waste from the mill house includes the waste water used for splashes to extract maximum amount of juice, those used to cool the roller bearing. As such, the mill house waste containing high amount of BOD due to the presence of sugar, oil from machineries, the wash water thus produced through the small in volume contain high BOD and suspended solids. The large volume of water is required for barometric condenser of operators and vacuum pan. The cooling waters get polluted as it picks up some of the organic substance from the vapor of boiling syrup in operation and vacuum pans. These discharges contribute sufficient to the waste volume and modulated to BOD many sugar mill. So that's what I discussed here. From the washing of rollers, you get some amount of water where you're going to observe the grease and oil etc. here. Then filter cloth washing, you're going to get sufficient amount of BOD here, and boiler house leakage, you're going to get some suspended solids. Evaporators, this is excess condenser cooling, you're going to get wastewater, and pond overflow, and in the during crystallization centrifugation, you get sufficient amount of wastewater. This has to be treated. Additional waste originate due to leakage and spillage of juice, syrup, and molasses in different sections. The periodic blow of the boilers produces another intermittent waste discharge. This waste is high in suspended solids, low in BOD, usually alkaline. So typical characteristics of cane sugar industry wastewater. pH will be, it is in acidic range, pH will be 4.6 to 7.1. Total solids 870 to 3500 milligram per liter is a very high amount. Then BOD 300 to 200 milligram per liter. COD 600 to 4380 milligram per liter. Total suspended solids will be 220 to 800 milligram per liter, and total nitrogen will be 10 to 40 milligram per liter. So here we are interested to neutralize one step, then suspended solids has to be removed, and BOD and COD has to come to normal. So what will be the effect of this waste on receiving water? The fresh effluent from the sugar mill decomposes rapidly after few hours of stagnation because of aerobic decomposition is going to take place. It has been found to cause considerable difficulties when this effluent gets an access to the water course, particularly the small and non-perennial streams in the rural area. Because it's having some amount of BOD, if it disposes on the stream, the river will get polluted unless otherwise self-purification will be less. The rapid depletion of oxygen due to biological oxidation followed by anaerobic stabilization of the waste causes secondary pollution of offensive odor, black color, and fish mortality. So that's why if these waste were directly disposed onto the stream or pond is going to be affected by the odor, color, and rest mortality. How we can able to treat? As I discussed earlier, the pH is in acidic range, more amount of total solids. The organic load of the waste come only by reducing the proper control on the operation. The overloading of evaporates and the vacuum pans and the extensive boiling of syrups leads to a loss of sugar to the condensed water, and this in turn increases the both volume and strength of the waste. So we are going to concentrate the sugar level here, then the volume and strength of the waste of the effluent increases. Disposal of the effluent on the land has irrigation water practice in many sugar mill, but associated with odor problem because of high amount of sugar in the wastewater. The effluent of anaerobic treatment unit are found to contain sufficient amount of nutrients like nitrogen and phosphorus. As such, further reduction of BOD can be accomplished in aerobic waste stabilization pond. So, nitrogen and phosphorus, which are present in the wastewater, can be utilized in aerobic waste stabilization. So it is the typical wastewater treatment plant. First steps, you are going to have a screening process where you are going to remove the suspended particles may be originated from the crushing of the sugar cane. Then later you go for a grease step where you can, first step is going to remove the grease. It's a physical process where you're going to remove oil and grease as well as the suspended particles. Second, you go for equalization tank because of is having high amount of acidic range. So you go for equalization where you're having detention period of 1 day. Then the next step will be you're going to have a aerobic lagooning where BOD is going to be oxidized by microorganism. Here, the detention period will be 6 days. BOD loading will be 0.24 to 0.32 kg per meter cube per day. Once here sufficient amount of BOD is decreased, then you go for the waste stabilization point where the wastewater is going to be stabilized for 12 days. So importantly, in sugarcane industry wastewater, mainly we come out with removal of physical process and secondary biological treatment. In biological treatment, here going for aerated lagoons and waste stabilization pond. This is the how procedure we are going to treat this wastewater. These are the some MCQ question. Dash is the one of the byproduct from the sugar industry is a bagasse, where this bagasse will be used for paper or as a fuel. So one of the steps during the refining of cane sugar consists of the addition of hydrated lime to sugar syrup is to remove coloring matter from the syrup. So the coloring matter which is come from the sugarcane juice which will be removed by adding hydrated lime. The primary objective of clarify is to remove maximum amount of impurities. Generally, these impurities is nothing but suspended solids. The aerobic treatment involves degradation of organic matter in the presence of oxygen. Because it's aerobic treatment, in lagooning, we are going to remove this BOD. The purpose of adding soluble phosphate in the clarification process is to clear the juice. So you remove the dissolved or suspended solids from the juice. So clear juice will be go for the next process. So this is the procedure we are going to use in sugar industries where water before disposing on land or water bodies has to be treated. Thank you.